Hi everyone, welcome again. So to continue the interview series for the Spark interview preparation, this is the second video. In this particular video, we will be talking about partitioning and bucketing from interview point of view. When I say interview point of view, we won't be doing practicals. We won't be doing a lot of coding, but it will be what type of questions asked in the interview and how to answer them, right? In the first video of this series, we have covered about general questions which are asked in Spark, and majorly we focused on joins. And I think we have covered almost everything, every scenario about joins. We will be following the same pattern. We will be talking about partitioning first and then bucketing, and then we will be covering around 45 to 50 questions in this particular series. And one thing I can assure you that, okay, if you follow these 45 questions, I think it will cover 90 to 95% of interview questions from partitioning and bucketing. And if I miss something, again, there's a comment section. Please do share your knowledge so that everyone can get benefit from, right? So let's start with all about partitioning in Spark, bit about theory, then we will touch bucketing, and then we'll jump to questions, right? So in Apache Spark, partitioning refers to the process of dividing the large data into smaller, more manageable chunks called partitions, right? This allows Spark to process the data in parallel across multiple worker nodes, which results in improved performance and scalability. Each partition can be processed by single executor in the cluster, and multiple partitions can be processed in parallel to improve performance, right? So partitioning is performed on RDDs, which are the basic data structure of Spark. Spark provides several methods of partitioning data, including hash partitioning, range partitioning, and custom partitioning. We will be covering this in Spark interview questions later, but let's see what is hash partitioning from on very high level, right? So data is partitioned in hash partitioning based on the result of hash function applied to the key in the data. Range partitioning, data is partitioned on the value of keys in the data, or range of the keys in the data. What is custom partitioning? In custom partitioning, you will be writing a custom code with a specific logic to perform the partitioning, right? Now the question arises, which type of partitioning method you need to use. So choice of partitioning method depends on the data and the requirement of the application. It is important to choose the appropriate partitioning method to ensure efficiency to process data in the Spark, right? And we will be touching about from industry point of view how and why and when to do partitioning. So when partitioning the data in Spark, it is important to consider few things: size of the partition, distribution of the data within the partitions, distribution of data across the nodes in the cluster. The goal of partitioning is to ensure that partitions are balanced, so that each node in the cluster has a similar amount of work to do and the data is distributed evenly across the nodes. There are multiple methods to do the partitioning. We can use repartitioning and coalesce, and we will be touching them later. See, it is also important to consider the level of parallelism in Spark application, which is the number of tasks that can run in parallel. The level of parallelism can be set using two properties. One is spark.default.parallelism, and it can like we can also set the numPartition argument, right? So this is on very high level what partitioning is. So if somebody asks you what partitioning is, and if you answer with these particular points, I think interviewer should be well satisfied with the answer, right? Now let's jump to bucketing. So bucketing in Apache Spark refers to the data partitioning technique again, where data is organized into fixed number of buckets. So each containing specific number of records. So how partitioning and bucketing is different? So bucketing is based on the hash function, and the data, each bucket will contain a specific number of record based on that hash function. Let's see how it works, right? So bucketing is used to improve the efficiency of certain type of operations such as joins and aggregation by reducing the amount of data that needs to be processed. Spark supports bucketing for both Parquet and Hive tables. In order to bucket a table in Spark, a bucketing column must be specified, right? So, which is used to divide the data in the specified number of bucket. The bucketing column must be the type of integer or long. The number of bucket must be specified by using bucket num argument, right? So when bucketing is used in Spark, the data is physically stored in a specified number of files where each file contains the data of single bucket. This results in improved performance for the operation that can take advantage of bucketed data as they can execute more efficiently. Now let's go for example, right? So for example, when performing a join operation, Spark can take advantage of bucketed data to perform more efficient sort merge join, as data for each bucket is already sorted. Similarly, when performing an aggregation operation, Spark can take advantage of bucketed data to perform the aggregation in more efficient manner, as the data for each bucket can be processed independently. So I think this paragraph is important, this particular, and why this is important, because it is exactly telling you where and how the buckets can be used in joining and aggregation. In summary, if we summarize this, what we have covered so far, bucketing in Spark is a data partitioning technique that is used to improve the efficiency of certain operation. It is also important to note that bucketing is not always the best solution for all the scenarios and data structures. The choice of whether to use bucket or not depends on the specific requirement of application and the characteristics of the data. It is recommended to carefully consider the trade-offs between bucketing and other partitioning technique before implementing this Spark application. Okay. So in addition to the benefit performance for certain operation, bucket has other number of advantages, and this is important. Please read it carefully. Let me highlight it for you guys. So let's highlight this part, is important, and this part I think is not available anywhere readily on even on internet, right? So what bucketing brings to us, the most important bit is it reduces the storage overhead. What it means that bucketing can result in reduction of storage overhead, as the data is stored in smaller number of files, each containing the data for a single bucket, and this leads to reduced number of input output operation and improvement of overall performance. The second thing, improved query performance. See, first point, reduced storage overhead, and the second point, query performance, are interrelated. Since we are performing query on certain amount of data, it means there is less disk input output that leads to better query, and that's written in that way, right? Improved data locality. So when data is bucketed, Spark can ensure that data for a single bucket is stored on a same node. Improve data locality and reducing the amount of data needs to be transferred over the network. So it means bucketing prevents shuffling in very simple terms. However, now these are the benefits, but if somebody asks you what are the limitations, so it means limited number of buckets is the first limitation. The number of buckets that can be specified when bucketing data in Spark is limited. So it may not be possible to achieve perfectly balanced distribution of data across buckets. Immutable bucketing. So it means once the bucketed table is created, it's almost impossible to change it. You might need to drop it and do recreate it again, but you cannot change it. Unbalanced bucket. So if your data is skewed, if there is data with unbalanced keys, uneven distribution, then it will lead to the suboptimal performance, because one bucket might have more data, other bucket might have less data. So it means one node might need to perform more work than others, right? Okay. So how to do bucketing and partitioning? It's very simple. So obviously you will first create your Spark session, right? You will read your data in some RDD called df, right? And spark.read.format csv option header is equal to .load data.csv. So it means this df is created for you. Now if you want to partition it, you can partition it based on some column name using repartition clause, right? And how to do bucketing on this partition df, you can call dot bucket by and then column name, and then you can save it, right? So this is on very high level all about partitioning and bucketing, but we haven't covered the interview questions yet. So let's jump to interview questions. What you will see now, that all the interview questions will be around the concepts what we have discovered in the first 5 or 10 minutes of the video, right? So let's jump to interview questions. If somebody asks you what is Spark partitioning and why it's important, so you need to answer in this way. Spark partitioning is the process of dividing large data set into smaller, more manageable chunks known as partitions. This allows Spark to distribute the data across nodes in the cluster, making it possible to process the data in parallel. Partitioning is important because it can greatly improve the performance of Spark operation by reducing the amount of data that needs to be shuffled and processed on each node. Simple. So this 4 or 5 lines, if you answer, you are good to go. How does Spark determine the number of partition for a given RDD of data frame? This is great question, and I'll highlight it so that because the answer for this question is there are multiple factors. So data, the number of partitions is decided by n number of factors. The factors like configuration setting for the Spark cluster, amount of available memory, the size of the data. By default, Spark will create one partition for each block of data in SDFS. So I will highlight this again, and this is important. And people might ask this as well, okay? So by default, Spark will create one partition for each block of data in SDFS, which is typically 120 MB. However, number of partition can be manually adjusted using repartitioning coalesce method. We will cover repartitioning and coalesce in a lot of details, okay? Okay. Third question, how does Spark partition the data in cluster, and what are different partitioning method in Spark? We have already covered on the top when we were seeing the overview of the partitioning. So Spark will do partitioning on n number of methods. The most famous are hash partitioning, range partitioning, round robin partitioning, and custom partitioning. Hash partitioning will be based on the hash value of a specified column. Range partitioning will be based on the range of value of that specified column. Round robin means data is partitioned evenly across all the nodes in the cluster regardless of values in the data, right? So evenly across all the nodes in the cluster regardless of the value of the data. For example, if you have 5 nodes, first chunk of data or the first row will go to the first, second row will go to the second, and in the round robin way it will be stored. It doesn't matter what's the value of the data. Simple. Custom partitioning, you will write your custom logic and it will be implemented as part of partition later. Okay. So this is about partitioning. The fourth question is, can you explain how bucketing in Spark works and when it should be used? So bucketing in Spark works by dividing data into fixed number of buckets, where each bucket is a separate partition. The data within each bucket is hashed based on the specified column. The hash values are used to determine which bucket the data belongs to. Bucketing should be used when the data is skewed, so this is important. I'll highlight it for you. This is again important, so I'll highlight everything which is important, and you need to ensure that data within each partition is evenly distributed. This can improve the query performance by reducing the amount of data that needs to be shuffled during execution. Okay, how does Spark perform data shuffling and repartitioning when joining 2 large data sets? Okay, this is again an important question. Let's highlight it. So when joining 2 large data sets in Spark will first partition both data sets based on the join key. This helps to minimize the amount of data that needs to be shuffled between nodes during the join operation. So first we will partition the data based on the join key, and then the joining will take place. After data sets are partitioned, Spark will then perform a shuffle operation to redistribute the data based on the join key. Ensure that all the data of a given join key is co-located on the same node. So if there are multiple join keys, so what Spark will do, Spark will obviously bring all the data related to the single join key from different tables to the same node, and then it will join it, right? Finally, Spark will perform join operation by processing the data in parallel on each node and producing the final result. Can you describe the scenario where bucketing can lead to performance optimization? Okay, so bucketing can lead to performance optimization in Spark when joining large dataset with a skewed distribution of the join key. For example, if you are joining a large fact table with a small dimension table, bucketing the dimension table can help to reduce the amount of data that needs to be shuffled during join operation. By bucketing the dimension table, you can ensure that data is evenly distributed across the nodes in the cluster, which can help you to reduce the amount of time required for the join operation. How can you manually control the number of partition in Spark? And what is the impact of having too many or too few partition on the performance? Very important question. Very, very important. Let me highlight it. You can control the number of partition in Spark using two methods. One is repartitioning and one is coalesce. The number of partition can have significant, and I will be covering repartitioning and coalesce later. Let me highlight it. The number of partitions can have significant impact on the performance, as having too many partitions can result in excessive shuffling and overhead, while having too few partition can limit the parallel processing capabilities. So it's important to strike that balance between number of partition and the size of the data to ensure optimal performance. Okay. Next question. What is the trade-off of using Spark partitioning and bucketing, right? So trade-off means what extra overheads are coming with these both methods, right? So increased overhead for shuffling and redistributing of data between nodes. So whenever we do partitioning or bucketing, obviously data movement will take care. It means data for single key or single bucket will go to one file, and this with a lot of shuffling and redistribution of data between the nodes, right? Increased memory usage, as more data is stored in the memory for on each node. Potential of for data skew, which can impact performance if not addressed. Last one, the need for manual testing and optimization of the number of partition and bucketing strategy to achieve optimal performance. So obviously, see, partition and bucketing bring lot of performance, a lot of benefits to us, but these things we need to take care. So what I'm trying to convey here, that okay, you guys should have full knowledge of trade-offs, benefits, performance tuning and everything. Okay, how does Spark handle data skew in partition dataset, and what are the available strategies to address it, right? Spark handle data skew by redistributing the data to ensure that each partition has the same amount of data. There are several strategies for addressing data skew, including using bucketing to ensure data is evenly distributed across within each partition. Repartitioning the data to balance the load across nodes, using custom partitioning strategy to partition the data based on custom logic that takes into the account the distribution of the data. On very, very simple node, how to work with skew data, go for bucketing and partitioning. Keep in mind the data using these two methods should be evenly distributed after you do partitioning and bucketing, right? Can you explain Spark dynamically adjust the number of partition during execution of the query to optimize performance? So how Spark will do the dynamic partitioning, right? So Spark dynamically adjusts the number of partition during execution of the query to optimize performance by using a technique called dynamic partition pruning. It means Spark will start the large number of partition, then dynamically adjust the number of partition as the query progresses based on the size and distribution of the data. Simple. Can you explain how Spark uses partitioning for data processing and improves the performance compared to the non-partition data? We have covered it, but let's quickly read it. Spark uses partition to divide the large dataset into smaller datasets, so the manageable chunks can be processed in parallel on multiple nodes of the cluster. Each partition is processed on separate node, which allows Spark to parallelize the processing of data and distribute the load across the cluster. Partitioning helps to improve the performance of Spark data processing by reducing the amount of data that needs to be processed on each node, right? And when we talk about non-partition data, obviously everything opposite to it, right? So it might not be able to utilize the full parallelism of the cluster. The data might be one worker node might be busier than other worker node. That's where partitioning and bucketing will help, right? How does Spark determine the number of partition of given data sets, and factors impact the optimal number of partition? I think we have covered it. The size of the data, cluster configuration, and memory available, right? Desired number of parallelism. The general rule of thumb for number of partition, this is important. So let me highlight it. So general rule of thumb to aim the number of partition that is equal to the number of cores in the cluster, as this allows the maximum parallelism. However, exact number of partition required will depend on the specific use case and should be optimized based on the performance testing. Can you explain how Spark handles partition shuffling and how it affects performance? Partitioning and bucketing both will bring shuffling on the table. Why? Because shuffling means moving data here and there across the network. So Spark handles partitioning by shuffling by redistributing the data across the partition in a way that balances load and ensure that each partition has roughly same amount of data. This is necessary when performing operations such as join and aggregation that require data from multiple partitions to be combined. Partition shuffling can be a network overhead. To minimize the impact of partition shuffling, Spark uses optimization techniques such as pipelining, data compression, to reduce the so this is, again, I'll highlight it or I'll just bold it. The reduce to reduce the amount of data needs to be shuffled and improved the query performance. Can you explain how Spark uses bucketing to improve the query performance and how bucketing is different from partitioning? I think we have covered it. Let's read it quickly. Spark uses bucketing to further divide partition into smaller, more manageable pieces of data called buckets. So we can do partitioning and then bucketing. Bucketing will bring more manageable chunks based on the hash value of the column. Bucketing helps to improve the query performance by reducing the amount of data that needs to be processed during query execution. Bucketing is different from partitioning, that is applied at the finer granularity with each partition. So let's say you have a data which has data for each state, right? So in India there can be, let's say, 29 states, right? So there will be 29 partition. Now you want to bucket the data based on the age of the person. So the person age can be from 1 to, let's say, 100. So there will be 100 buckets in each partition. Simple. And with each bucket you will have more granular data. So once you say, let's say you are writing a query, select a star from table name where age is equal to 100. So it will go to, and state is equal to, let's say, Delhi, right? So it will go to the state Delhi and then it will go to that particular bucket. It means the query performance will be improved because it is just targeting only a specific amount of data. Can you explain with example how to specify number of partitions? Yeah, so we can use repartition clause and then we'll mention number of partition here. So it's simple. You'll create a data frame using read spark.read method, and then you will just pass num partition in repartition method, right? So it will create, let's say, 5 partitions here. Can you explain how to perform partitioning, partition shuffling in Spark? So in simple, right? So partition shuffling means what? First of all, so it means shuffle the data during partitioning, right? So you'll create 2 data frames and then you will join the data frame 1 with data frame 2 using inner join, right? And then you will do the repartitioning 100 based on some column name on join data frame. So it means A joint data frame will be a partition based on the column name in the joint data sets, right? So what this example is doing, we have two data frames, df1 and df2. The resulting data frame is joint df. When we are joining them, we'll have number of partition data might Spark default partitioning strategy. So this particular data frame, joint data frame, will have, let's say Spark default parallelism is 120. So it will have 120. To perform partitioning shuffling, the repartitioning method is used to redistribute the data based on the column name column, right? And the goal is to have 100 partition. So simple. So if we are changing the partition, default partitioning of Spark, it's causing shuffling, and that's called partition shuffling. Simple. Can you perform provide an example to perform bucketing in Spark? Simple. You will create a data frame. So whenever somebody asks this question, I think where people are lagging, they know how to answer, but they don't know how to write code on the runtime. So the most important bit when we answer this type of question, have few things in your mind. For example, this and this, some important point. For example, forget about everything, but when we talk about bucketing, bucket by is the key thing for you. So you will say dot bucket by 100 column name. It will divide the data into 100 buckets based on the column name. Simple. So if you answer this question in such a way, nobody will stop you from getting selected. In this example, data frame is read the CSV file, right? And then save as table method is used for saving all the buckets. Okay. Can you explain the difference between partitioning and bucketing in Spark? We have covered it. Can you do bucketing and partitioning in a same table? Yes, we can do it. What is bucketing in Spark and how does it improve the performance? We have covered it. Bucketing will bring more granular data, right? So bucketing in Spark is a way of grouping similar data together for optimized execution. And when we do operations like group by and join by reduce, it will reduce the amount of data that needs to be scanned, right? How bucketing can be used to improve the performance of join in Spark? I think this I can cover. Bucketing can be used to improve the performance of join operation in Spark by reducing the amount of data that needs to be scanned. Everywhere it's talking the same thing, but let's see how it is different in join. When two data frames are joined, Spark has to scan both data frames to find the matching rows. However, if both data frames have been bucketed on the join key, Spark can access only the relevant buckets, reducing the amount of data that needs to be scanned and processed. Okay, let me highlight this and I'll explain it now. So first of all, let's bold it. So what it means, you have two tables bucketed on the same key, joining key. So now we know, let's say join key is age, right? So we want to bring people who are of age 20 from Delhi state and let's say from Maharashtra state, right? So if it is not bucketed, what it will be doing, it will bring all the data, it will find out the people of age 20 and then it will bring them to the same table or the same executor and then it will perform it. So there will be a lot of scanning. Now if this is bucketed, this bucketing information will be in metadata and it will know, okay, bucket of age 20 is on this data node, right? And now to bring bucket from other state of age 20, it just need to bring that bucket to this other state bucket and they'll join it. So it will be faster because obviously you are only scanning particular amount or particular set of data. So important here. Why should number of buckets be the multiple of, okay, this is important. Let's highlight this question again. So why should the number of buckets be the multiple of number of executors in a Spark cluster? Number of buckets should be multiple of Spark cluster because it helps to ensure that executor process roughly same amount of data. Simple. If you have 5 worker nodes, your job will be completed when every worker has done its work and informed to the master. If 4 workers has done the work and fifth worker still working, then your job might is not completed. So it means where bucketing will help you to redistribute the data on each worker in balanced manner. This is first thing. And let's say if you have 5 worker and you have 10 buckets, so then what it means that okay, almost every worker will have 2 buckets. So this is why there the multiple of executors and the multiple of buckets should be same and it will work. For example, let's say if you have 8 executor and 100 buckets, if the number of buckets is not multiple of 8, some executor might end up processing more buckets than other, leading to the uneven distribution. On the other hand, if the number of bucket is multiple of 8, such as 96, right? Each executor will having equal number of buckets, resulting in even distribution. In general, it is recommended that number of buckets to the number of executor in the cluster to have the optimal performance. Simple. Why it is important to use same number of buckets for data frames when performing join? We have covered it. It's almost same. What are the changes and improvements? Oh, that's great. I think this interview question is asked a lot. In Spark 3.0, what extra has been brought to the table? So dynamic partitioning pruning, improved write performance, interoperability, improved management of bucket files. These are 4 points. So let's go for dynamic partitioning pruning. In Spark 3.0, I did the ability to dynamically prune partition when executing a query. On the write performance side of the bucketed table, making faster and more efficient to write data to disk. So it means it's more efficient when we are writing data to the disk. And when we are talking about interoperability with other data sources, it means bucketed table with other data sources, allowing data to be more easily read and written from the variety of the data sources. So this is only specific to bucketing, but what I will be covering in the next video, we will be comparing different versions of Spark, what extra has been brought to the new version, because I think people or interviewer want to know how updated you are with the latest version. You might not be using 3.0, you might be at 2.7, 2.8, but as a data engineer, a Spark engineer, you should know what is new, you know. Can you provide the example of dynamic partitioning pruning? So let's see. When we execute a query to filter data based on a specific date range, Spark will dynamically prune the partition that are not needed for the query based on the filter condition. For example, if the query is to retrieve data for the date range from 1st of January to 5th of January, Spark will only scan the bucket that contains the data for the specific date range and ignore the other buckets. This will help reduce the amount of data to be scanned and processed. Let's see how it works. So basically, we will create this Spark session. We will read the data. We'll create a new data frame. We'll write the data and we will say bucket by based on the date. And we will divide the data into 10 buckets and then we will save the data as a bucketed table. So till now, this point, we have done the bucketing based on date. Now, once we execute the query, for example, select a star from bucketed table where date between 1st of Jan to 5th of Jan, and then we will show the results. In this particular case, once this action is hit, Spark will do the dynamic partitioning pruning based on this particular date. So it means it will only go to these buckets and it will give the data to us, right? What are different type of partitioning? I think we have covered it, but we haven't covered when each type of partition should be used, right? So when we talk about hash partitioning is used to distribute data evenly across partition. It is suitable when data is evenly distributed, such as when working with large data set with no skewness. Range partitioning is used to partition based on values of one or more columns, right? It is useful when working with the data that has an inherent ordering or date or time based data. Important. Again, this point is important. Let me highlight it so that you guys can focus it on once you are watching this video. Round robin means this type of partitioning allows you to manually specify the number of partition. See, the benefit of round robin is every partition will have every executor will have same amount of data. The data might not belong to the same key, but let's say if you have 10 gigs of data, you have 5 partitions, you have 5 executor. If you go over round robin partitioning, every worker will have 2 GB of data, simple. Because obviously one row on the first, second row on the second, fifth row, and then it will round robin, right? Manual partitioning or custom partitioning, if you have some business logic which is not available in hash, range, or round robin, you'll go for it. Can you provide more details on partitioning? I think this is good. We have covered it. Can you provide more details on hash partitioning? Okay. I think this is on range partitioning. So I think range partitioning in Spark is type of partitioning to distribute the data into partition based on the values of one or more column. We have covered it. So this is how you'll, there's a function called range partitioning as well. I'll cover it later, but you can use range partition here, right? Partition. I'll cover it. We have covered hash partitioning as well. So the type of partitioning, the hash partitioning is useful when data is evenly distributed. There is no skewness, such as when working with large tables. The hash function ensures that each partition contains some small similar number of records. This is how you will do the hash partitioning, right? Okay, this is range partitioning I was talking about. What is repartition by range method in Spark? Repartition in range method in Spark used to perform range partitioning on a data frame or data set. It can take one or more columns at the partition key and divides the data into a set of range based on the values on the partition key. Each range is stored as a separate partition. Repartition by range method allow you to control the number of partition in the output data frame and data set to specify the column used for the partition. Let's see the example. So you'll initialize the Spark session. You will load the data, and let's say you are reading a parquet. When you do this repartition by range on some column, let's say date, and you are telling that, okay, based on the days, divide this data into 10 particular partitions, right? So what it will do, Spark will perform range partitioning on the date column and distributes the data into 10 partitions. The data in each partition will be sorted by values of the date column, allowing Spark to more efficiently process queries. So this is important. This is important. The sorted, right? The data will be in the sorted format. Allows Spark to more efficiently process the queries that involves filtering, aggregating based on the date column. Okay. Is number of bucket important in joining? I think we have answered this. Yes, the number of buckets can play a crucial role in performing join operation in Spark. When performing join, Spark uses data in the bucket to avoid shuffling and the entire data across the network, leading to the faster and more efficient join operation. Ideally, number of buckets should be the multiple of execute in the node, and I think we have covered it in previous question. Okay, Spark and Hive. Okay, the partitioning and Hive in Spark, how they're different, how they're similar. Okay, so let's see. Spark and Hive both supports partitioning, but there are some differences. Type of partitioning, Spark supports multiple type of partitioning. I think this should be range, hash, and everything. Partition key, in Spark, partition key can be any column, while in Hive the key must be okay. The most important bit, which we will be covering later in this particular answer, is in Spark you can do partitioning at any time, but in Hive you need to tell the partitioning bucketing at the table creation time. Simple. And everything is written in that direction only. So in Spark, partition key can be any column, while in Hive it should be specified at the table creation time. Dynamic partitioning, Spark support dynamic partition where data can be partitioned at runtime based on the partition column. Hive requires partition key to be specified when inserting the data into the table, right? Let's talk about performance quickly. Spark partitions are stored in memory and can be accessed directly, making partition data much more faster than Hive. Overall, both Spark and Hive support partitioning. Spark offers more flexibility, better performance in partition data. Dynamic partition we have covered. Dynamic partition. What is dynamic partition in Spark? Dynamic partitioning in Spark refers to the process of repartitioning data in a flexible way, such as number or location of partition can be determined at the runtime. This is achieved by using partitioning function that can be customized based on the data being processed. Now, the most asked question: what is repartitioning in coalesce? Right, so repartitioning and coalesce are two Spark operation that is used to control the number and location of the partition in Spark's data structure. Repartitioning refers to the process of creating a new RDO data frame with a different number of partition. This is useful when number of partition in the original data structure is not optimal for processing and you want to adjust it. For example, you might want to increase the number of partition to parallelize the processing, or reduce the number of partition to reduce the overhead of shuffling data. Now, this is important again. You can use repartitioning for increasing and decreasing both. Coalesce refers to the process of reducing the amount of partition in data or identity. This can be useful when you want to reduce the number of partition to reduce the overhead, right? Both repartitioning and coalescing can be used to control the partition in Spark API. How to do it? You will use repartition method to increase or decrease the number of partition, and you will use coalesce method to decrease the number of partition. The important point, which might be covered later: coalesce will not cause shuffling, but repartition will always cause shuffling. Okay, so repartition can be slower, but coalesce will be faster. Okay, here are some example of repartition and coalescence. Okay, this is important. When we talk about repartitioning, coalescing, people might ask, okay, where did you use it? I know, okay, you will say repartitioning can decrease the number of partition, coalesce will decrease the number of partition. But people will ask, where did you use them? When did you use them? And what is the use case? So therefore, this is important bit, and I'll highlight it in yellow. So both can be used for load balancing. So if you have skewed data, you can do this repartitioning and coalescing to ensure the distribution across the worker nodes. You will use this for performance optimization. You can use this for filtering and sampling. So if you need to filter or sample the data in a specific way, you can go for repartitioning. Join optimization. So if you need to perform join optimization operation on large data set, you can use repartition to control the distribution of data in each data sets, and then use coalesce to reduce the number of partition and join data sets. So this is again important. Shuffling operation can be reduced, right? Again, these are now the important questions coming. If you are working in, let's say, telecom industry, or you're working in retail industry, so where did you use partitioning and bucketing in the industry? So let's say go for retail data analytics. This is a problem statement. A large retailer, so let's say you are working in retail industry and you want to explain it. So how will explain the partitioning and bucketing industry? Let's say the large retailer, you take the company name, is collecting sales data from multiple stores and needs to perform data analytics on the customer behavior, product popularity and sales trend. The data is collected in raw format and stored in a data lake as a large Parquet file. So this is your problem statement. It means you will explain what was the problem statement, why you are doing this thing. You want to do the customer behavior analytics, sales trends. A solution, what was proposed to optimize the performance of the data analytics operation. The retailer can use Spark partitioning and bucketing to divide the data into smaller and manageable chunks. So this is where you can use Spark partitioning. Okay, now let's see how partitioning work and on which column you can do the partitioning. The retailer can use Spark partition by function to divide the data into partition based on date of the sales transaction. So partitioning is done on the date. In this way, data can be easily grouped and analyzed by date, making it easier to understand the trend over time. Now, where the bucketing can be used? The retailer can use Spark bucket by function to divide the data into smaller, more manageable chunks based on customer's age. See, why I'm focusing on this? Because you know the theory, but did you use them? This is where interviewer want to see it, right? Where is metadata stored about bucketing and partitioning? In Metastore. So everything is stored in Spark Metastore. What is Spark Metastore? It's a centralized repository that stores the metadata of Spark tables such as schema, location, date, format, and so on. So everything will be stored in Metastore, right? By default, Spark uses an embedded Derby database, but this is not reliable. Only one process can use it. So you'll go for external Metastore such as MySQL, Postgres, Oracle, Hive Metastore can be used as well. How do you configure the number of partition? We have done it many times. You use repartition clause, right? What are the performance consideration when partitioning in Spark? Okay, so there are multiple performance consideration. For example, number of partition. So this is the most important performance consideration when you do partitioning. If you create too many partition, it will lead to the overhead in communication data supplying, while too less partition can result in underutilized cluster resources, right? Partition size. The size of each partition should be appropriate for the available memory. So the partition size is again important. Data skewness, that okay, data should be evenly distributed across the cluster for the performance, data locality, cluster configuration, and use case. But I think these 3 things are important, so keep in mind. Number of partition size, data skew, right? Drawbacks. Okay, we have covered lot of benefits of partitioning and bucketing. What are the drawbacks? So I think we have covered in the last question about trade-offs. Trade-offs and drawbacks are almost same thing. So if you do the over partitioning, there will be over or shuffling. If you do the under partitioning, the cluster won't be used properly. Partitioning and bucketing bring complexity, right? To Spark data processing pipeline, because it increased to the complexity will increase because you need to maintain them, right? If data is skewed, it will be tough. Bucketing can cause data issue where certain buckets can have more data, which can result in imbalance. See, this is not always available or applicable, but you should be knowing this. How to delete the partition in a Spark? So deleting partition and require, okay, can you delete a partition in Spark? Not directly. To delete the partition, you need to delete the data frame, or you need to create a new data frame again, right? So deleting a partition in Spark requires to change the data stored in the underlying file system. So you need to change the underlying file system. You can't delete a single partition in the place. Instead, you need to recreate the data frame or the data set without the partition you want to delete. Simple. So let's say I don't want to create the partition for the people who are of age 20. So what I can do, rather than I delete or modify my base data set which is stored on HDFS, I'll do filtering and then I'll create the partitioning. Simple, right? And that's what I'm doing here. So df without partition, I'll filter on some partition column. Based on the partition column I need to delete, and then I'll write the data and I'll do the partitioning later, right? So when we talk about bucketing, we have talked about the partitioning industry use cases. Now what is the bucketing industry use cases, right? So bucketing can be used in retail. Retail, we have talked about that. Okay, if you need to store data based on customer age and you need to do analytics, you will do the partitioning based on the date, and then you will do the bucketing based on the age of the customer. In healthcare, bucketing can be used to optimize patient record analysis. For example, by bucketing patient record on the patient age, Spark can quickly retrieve the specified age group. In financial services, you can bucket the transaction data based on customer account type, and then you can go for the transaction, right? So these are particular example. For example, in telecom, you can, to optimize the call CDR, call detail record, you will bucket CDR data based on caller's phone number. So let's say you have 1 million customers, so you'll have 1 million buckets, but in that each bucket you will have the call information of each mobile number, and once somebody asks you, you can query the bucket directly. Okay. Number of buckets. Okay, now this is important again. So with SQL data frame, the default number of bucket is 200, and that is set by spark.sql.shuffle.partition. But it can be changed, and it should be changed. You can change it using repartition, or you can change it. You can get the number of partition method right afterwards. Hadoop block size relation, I have covered it. So there is one-to-one relationship between Hadoop block and the partition. So let's say if you have 5 blocks in HDFS, there will be 5 partition created in Spark. This question has been asked multiple times because people interview want to know how basic you know about it. What is the relationship between partition and jobs in Spark? So there's no direct relationship, right? Relationship between partition and Spark job is that partition define the parallelism of the Spark job. So there is no direct relationship. Like it doesn't. If you have 100 partition, there's no direct relationship that okay it will create 100 jobs. But if there are 5 jobs created, then this number of partition will define the parallelism, right? Now there is a relationship, direct relationship between partition and task. Number of partition should be number of tasks, because task is other name in Spark for parallelism, right? So this is the last question, where actually somebody asked me to add this question: how skewness and bucketing can be implemented in a practical way, right? And how bucketing will help in to perform the skew join. There is a new feature in Spark 3.0 in adaptive query execution. AQE will be covered in the later video. I think maybe third or fourth video will be related to AQE. But in normal Spark, how it will be done? So you will create a table called left table. You will bucket that table on column 1 into 10 buckets, right? You will load some data into it. You will create the right table. You will bucket that right table on the same column 1 and divide the into 10 buckets once and insert the data. Once you perform the join, column 1 join with column 1 of the right table and left table, since both tables are bucketed on the same column, the join will be faster and the skewness can be resolved because of this. Why? Because both tables have same number of buckets, both tables have been bucketed on the same column. So by using bucketing, Spark can perform join more efficiently, reducing the time it takes to execute the join and alleviating this skew join problem. So that is all I think related to the buckets and partitioning. One thing I can assure you that if you revise or if you watch this video end to end, your bucketing and partitioning in Spark is 100% covered. Once again, I'll say thanks to you for watching this video. Please do subscribe the channel, like it, share with your friends. I know there's so many layoffs in the so many companies. I will try my best to create more videos. Next video might be on performance tuning, then AQE, and we will cover everything what we can. And please do comment. For example, the last question I have included because somebody commented on my last video. So please comment, like, subscribe, and keep learning, keep growing. Thanks again.